Alright, guys, welcome back to the continuation of our lecture series on information retrieval and text mining. Uh, the last time we looked at some of the techniques that we can use to be able to build an intelligent IR system. We make decision as to whether we should drop stop words or not. Today we shall look at normalization as part of the techniques that can help to build intelligent IR system. So normalization simply tries to find classes that are equivalent, classes of terms that are equivalent. So what we try to do is uh, we match tokens in the query with tokens in the token list of a document. That is an easy case. So we have a query, we have the token, and we have a list of tokens list for the document, and we try to see a match between that. But then sometimes we can have some more complex cases where two character sequences are not the same, but a match between them is proper. For instance, when you have USA without a dot and USA with a dot, essentially they mean the same thing. So it's good to normalize. If we have this format of USA in our query, we can normalize it to this so that in expanding our query, we will include this also in our search so that uh, it will match anyone that contains this one too. So token normalization is a process of uh, localizing tokens so that matches occur despite superficial differences. So for another example here is anti-discriminatory without dash. We may match that together with the one with dash in both the document text and query. Okay, another thing we can do when we have car and automobile, we can simply say, okay, those are equivalent terms. Equivalent classes for query expansion is a fairly open research problem, and doing it seems a good idea, but doing it too much may have unexpected outcomes. So there are always trade-offs to this. For instance, cat and cat. Now, we need to make a decision as to whether we should make this cat to be equal to this cat. This cat could actually be the name of a company, and this could actually be an animal. So sometimes that may hurt. So these are some of the uh, uh, things we experiment with in building our intelligent IR system. So there's always a trade-off. Also, the accent and their critics. You may want cliche and cliche. So this one that has a diacritics, naive and naive to match. So we just remove the diacritics. But in some languages, diacritics are a regular part of the writing system, and they help to distinguish different sounds, which could lead to wrong meaning. So those are some of the things we may have to. Words may have different meaning depending on the use of the diacritic. For instance, in Spanish, when you have these diacritics on pena, it means a grief, and when it does, it means a sorrow. So that means if you match this with this, we'll go the wrong track. So all these are things that we have to take cognizance of to see when it's appropriate to match them, to equate them, and when it is not. Another thing is capitalization and case folding. You may want to reduce all letters to lowercase. For instance, automobile to automobile. You use heuristic to combine lowercase words at the beginning of a sentence and all words occurring in a title. But sometimes are distinguished only by case. For instance, General Motors If you change it to General Motors, then you completely lose the meaning, the semantic meaning, because this refers to a company. And Bush, by the time you change it to a small letter, you lose the meaning completely. So the advice is, do not reduce all words to lowercase for uppercase words that occur in the middle of sentences. So for instance, uh, uh, when you have something like bush occurring in the middle of a sentence, you should know that possibly it's not just referring to a kind of forest. It might actually be referring to the name of a person. So those are heuristics that you take cognizance of. Another thing is lemmatization. Lemma means dictionary. So you refer to return the base or the dictionary form of a word. So for instance, if you have ham, ha, is, you can reduce them all to be. So if you have any of these occurs in the query, you match them also with be. Car, cars, you can just return them to car. And so different, you can return them to differ. So you can match them to differ. You are returning the base word of different as differ. So how do we do this? You need a list of grammatical rules and a list of regular words, and from that list, that's where you'll be able to reduce all the words to their dictionary form. Spoken is reduced to speak. You also have stemming, which we mentioned before, which is cutting out the ending word. For instance, computer, computational, computation, or reduced to compute. So, correct morphological analysis is a language specific and can be very complex. Here is a link that shows some of the words that have been stemmed, common list of words that are used in English and their stem equivalents. So this can be incorporated into our IR design. So typical rules is, in doing stemming, when it ends with SE, SSE, S, you just replace it with SS, as in princess. When it ends with IE, S, you just place it with I, as in butterfly. But this might give a problems. Commission, when you have organization, organ, and replace it to organ. But this completely leads to something else. So this completely leads to something else. So it doesn't work here. So police, policy, if you turn it to this doesn't make any sense. Army, and you turn it to harm. This doesn't make any sense. So these are the pros and cons of doing stemming, and one has to be mindful of it and be watchful. So statistical properties of text. The question is, how is the frequency of different words distributed? How fast does vocabulary size grow with the size of the corpus? Such factors affect the performance of information retrieval and can be used to select appropriate term weight and other aspects of our system. Essentially, what this is saying is this: that if certain words occur frequently, they may not mean so much, and if certain words rarely occur, they may also not mean so much. So we need to be able to have a balance of checking the terms in our document and be able to weight them, attach a kind of importance to them based on how frequent they occur. So a few words are very common. Like two most frequent words, D of, can account for like 10% of word occurrence. And most words are very rare. And half of the words in a corpus appear only once. So how do we put a kind of parity on the rare words and the common words? So we call this a kind of what we call an heavy tail distribution, since most of the probability mass is in the tail. So, and this often affect how intelligent our IR system is, because if you decide to place too much priority on frequently occurring words, we might be building an IR system that will not be that will be skewed towards common words that will not give us important information for our IR system. In that case, it might even be better to put more weight on the rare words, which can help us to actually retrieve the document that matters. So here it's a figure that shows the frequent words and the number of occurrence and the percentage of how they occur. You can see clearly that D occurs 5.9% of the total words. This is taken from a track database. So still talking about the importance of words, we'll be looking at Zipf's law in the next lecture. So we'll be stopping here for now. Thank you for listening, and see you in the next one.